Welcome everyone. This video demonstration shows the SmartThings monitoring sensor device, an IoT device, an Internet of Things device. So diving into it, we can see the ESP module is connected onto the Arduino Uno module. We can see that is connected using the transceive and receive pins as well, so the TX and RX pins, and we could also see the enable and reset button, the pins connected together on the actual Wi-Fi board itself. So this is how the two devices communicate with each other and then onto the internet as well, or the cloud. And then moving on, we can also see the temperature. The TMP36 component is also connected up onto the Arduino with its ground wires as well, alongside the resistors, which is also connected onto the Wi-Fi module as well. On this circuit diagram, the green wiring is all the connections onto the various analog and digital pins. The yellow is for the RX and the pink is for the TX pins. And the red is for the 5 volts, so let me just move that back there, and the black is for the ground, and the brown is for the 3.3 volts of power. So as you can see, the temperature monitor is actually connected onto the Arduino board. Going back down onto the breadboard itself, we can also see the LCD screen, which is connected using its pins, which is also connected onto these pins right here, and then more over here, and it's also connected onto the positive 5 volts and the ground as well using the resistor. Moving on, this is the piezo and the gas sensor. So if it detects anything, the piezo, the buzzer, will go off, and I'll show you in a moment how the actual device fully functions. And this is a PIR, passive infrared sensor as well, with an LED, red LED light, so if someone is close to it, the LED light will flash. And this is a photoresistor, so it picks up light intensity, so if it is below 50%, the light bulb will switch on automatically, and if it is over 50%, the light bulb will switch off automatically. So let me just show you it in action. This is the device in action. As you can see, it reads out the temperature level as well as the gas level. So if I move the temperature more higher, it will reflect on the LCD screen as well, and if I move the gas, it will reflect on the LCD screen as well, which alerts the user of any temperature or gas fluctuations in the environment or in the given room. Also you can see the buzzer, the piezo, going off as well. So if it does detect abnormalities, so if you just detect a spike in the gas level, then the buzzer would go off. This is the PIR sensor, passive infrared sensor, in which it will detect presence within its close range, and if it does, then the LED light will also go off. And this is the photoresistor, so if it is below 50%, the light will turn on, and if it is above 50%, the light will turn off automatically. So these are all the features within this IoT device that I have created. As you can see, it monitors temperatures and alerts the user. It also monitors gas levels and alerts the user, as well as the proximity sensor. It also alerts the user of anyone else's presence, as well as turning the light bulb on or off automatically depending on the light intensity. Now if we go back onto the code, let me just give you a brief introduction around this code. So we include in the liquid crystal file library included within this to include the library needed to run the LCD screen. Then we're doing the pins, so all these pins here are set up correctly: 12, 11, 5, 4, 3 and 2, and then pin 6 is connected to the buzzer, the piezo. So pin A3 is also connected to the smoke sensor, and then we've also created a variable called the sensor threshold. So if it reaches this threshold of 350 degrees, that's when, sorry, not degrees, but 350 as in its own measurement. If it reaches that 350, above that, then the smoke sensor would go off, the buzzer. And then we also initiate a variable for the sensor state, for the PIR, to 0. So how it operates is a high or a low signal. And then we're also setting the pins here: A1 for the light sensor, the photoresistor, and pin 7 for the light bulb itself. Now for the ESP Wi-Fi module, you can see we've set up some variables for it, such as the value for the temperature sensor, the voltage and the temp, as well as the SSID for the Wi-Fi, the password and the host to the web application for the cloud ThinkSpeak, where all the variables or the values or the readings will go onto there, so the user could monitor it and do cloud analytics as well. Port 80 for the server, and these are the API, my API key for it to get transferred onto, and field 1 for table 1, table 2, table 3 and table 4, and I'll show you these on the actual website later as well. And this is the setup for the actual Wi-Fi model itself. So it begins the serial communication on the serial monitor, which I'll show you in a while as well, and it sets off the Wi-Fi command, puts a delay in, and if everything's okay, it will print out okay. And then set up the actual Wi-Fi connection itself, the SSID and password, but for this it could be blank because it's simulated Wi-Fi. And then we actually connect on to ThinkSpeak using a TCP connection. And once we scroll down, you can see that we've created a function called AnyData, and what AnyData is, it does the calculation on the reading and gets the right Celsius, and then what we do is create a HTTP packet and send it across to ThinkSpeak. And as you can see, it's got the various values needed in order to send it, and here's the actual value for the temperature sensor, and then we'll send it on. So each reading, each value from each of the sensors, so that's for the temperature, this is for the gas, this is for the PIR, the passive infrared, and this is for the light. So all these readings or sensor values will be getting sent onto ThinkSpeak, which you can be reviewed later on. And this is just a setup of the program itself, setting up all the different pins and the various inputs and outputs. For example, the Wi-Fi is put on input for A0, and we also start an LCD screen, the buzzer is set on output, and the gas sensor is set up on input. And you can also see the bulb configurations there as well. And then within the loop of the actual code itself, so when it runs continuously. We run the AnyData function, which is here, which I showed you earlier. Bear with me. Sorry, my eyes are playing up. Here we go. Here's the actual function which incorporates literally all the HTTP calls here as well. And then it sets up the variables for the different readings and also prints out the characters or the string for the LCD screens itself and its values to display for the user, and also puts it into the serial monitor as well. I've included this for testing purposes anyway, but I'll leave it on there for now. But in future release dates for upgrades to the project, I may remove these. And here is a conditional statement for the actual gas sensor itself. If it reaches above the threshold that I spoke about earlier, then the buzzer tone will ring, the peso tone will ring, and if it doesn't, there will be no tone. And this is for the PII sensor. If the sensor state is high, then there is someone within the vicinity, and if the sensor state is low, then there's no one within that vicinity. That's what I meant by high and low of the signals. And there's another conditional statement for the light bulb itself. Like I said, if it is below 50%, then the light will come on, the light bulb will come on, and if it's above 50%, then the light will switch off, and the condition is here, and that's the values. And that's it in a nutshell for the code. Let me just show you the simulation one more time. Just wait for it to start up. And there we go. So we'll go on to the photoresistor first, put it to full brightness, and you can see it's turned off. The PIR sensor, I move it about, as you can see it detects it, and the LED light comes on. And then for the gas level, if it reaches above the threshold, the buzzer goes off, or the peso goes off, as you can see here. And it's also displayed here with the temperature and gas on the LCD screen as well. So if I move the temperature up, that should correlate here as well. Now, moving on to ThinkSpeak. This is the actual web interface where you can actually do cloud analytics as well. So here you can see the temperature level that the interface is receiving values from an IoT device, as well as the gas level, PIR state level, as well as the photoresistor level. So all the information is displayed here for the user to see, and they could also do the analytics here as well to see what they can do, what they can improve on, or what's more vulnerable, for example temperature of gas. There's a lot of things you can actually do here, but for better visualization, what they've done, they've produced it as line graphs, so you could easily see it better and visualize it better. And that concludes my video demonstration.